Now, my other concern about all these trig limits is that people got so paranoid about these trig limits, so they just freak out whenever they see these theta or trig functions. They just do whatever they have, whatever ideas popped up in their head, they just do it. All right, so now I want to make sure that we all have the consensus right here about how to deal with limits. Your first and foremost approach is to simply substitute. You do not do anything special or crazy unless the situation asks for it. So in this case, we say, hey, is it okay to have this? Is it a problem? What's secant of pi? Well, secant of pi is the same thing as 1 over cosine of pi. And what's cosine of pi? -1. So therefore, done. Done. Right? But there are students who looked at this and say, wow, I got a trig function. I freaked out. I don't know what to do. It doesn't resemble anything like sine x over x. It doesn't have to be. Sometimes it's as simple as just plug in numbers. So do not have any presumption that it's going to be complicated. You start off with the most direct approach, which is straight up substitution. If something turns out to be weird, like 0 over 0, then and only then you start thinking about, oh, is it something else? Okay, but before you see anything weird, don't get overreactive. Okay, now here's another one that I would like to go over. It is this, all right. So the function, it's 1 minus tangent x, sine x minus cosine x. I think this would be a very good contrast. As I said, you just substitute. What is tangent of pi over 4? 1. And the numerator becomes 1 minus 1. Ooh, 0. Now you start to have a little flag wiggling, okay, swinging. And say, hey, what about sine x? Sine of pi over 4. √2 over 2, which is the same as cosine of pi over 4. So the denominator, it's also equal to 0. Oh, you've got to do something. Now, this cases like this, it's not, I mean, it's possible, but not likely to be DNE. But what is very likely that, and what's very likely? You got to do something. Now, what do we do? Well, that's not much to think about right here since, it's not like square. You're not doing like sine square plus cosine square. It's just sine, cosine, tangent. So the only thing that we can think about changing would be changing tangent. Now, and this is where I would like to inject my comments right here, and that is, this should be done with your mental math. You think about, all right, how good it is to implement this change. If I change tangent x to sine x over cosine x, will there be a way out? Does it offer us some benefit? This is where you got to think about, hey, if I do this, what's next? You think about common denominator. You combine the terms together with a single fraction. Now, can you see anything that could happen after having a common denominator? If you cannot see it, I need you to start training your eyes and your brain to see it. Can you see the outcome of having a common denominator? Because in the near future, when we start doing differentiation, well, I would like to share one observation by some older people on calculus, and that is, if you see it, you can do it. If you can't see it, you're stuck forever. So it's really heavy on the mental math. Can you see this mentally in your head? And if you could, can you see something special right here? Can you? Well, they're not exactly the same, but they're very similar. Because why? Well, you can factor out -1 from either one of these two highlighted expressions. So it becomes negative sine x minus cosine of x. And now the next thing is, are you comfortable in canceling these two out? How do you do common denominator? Right? Good old middle school math. Just don't let those go away. And if you say, I don't see how you cancel out these two, and I understand, because when I was a pre-calculus student, I couldn't see how that's done. So I can show you why they are canceled out, because you have this fraction right here, right? You have this fraction right here, and you're dividing this one, which is the multiplication of its reciprocal. Again, good old middle school math, but being applied in a more complex situation. So what do you have? Limit as x approaches power of 4 of -1 over cosine of x. And now -1 over root 2 over 2, which is -2 over root 2. Or if you want to rationalize it, it would simply be -root 2. So I want to give you a little heads up, and that is your mental math ability. And then I'm talking about just seeing some algebraic manipulations, like having a common denominator, seeing one step ahead. It's going to be so darn important. Okay? It's coming your way, it's heading your way, so do not be surprised that we will have this level of mental calculation. Okay? We're not talking about, hey, can you do 39 times 45 in your head? No, not that kind. That we reserve those kind of tasks with a calculator. But this algebraic manipulation, can you imagine what's going to happen if you have a common denominator? And can you see like something creeping up, being canceled out? Okay, so that's one of these situations there that you would substitute. And if something it's causing a bit of a concern, then you just go ahead and figure it out. Simplify it.